Hello students, welcome to a new lecture. In this lecture we will be studying about computer storages, not the computer storage that we have learned in the way in our high schools. Uh, here we will be learning about the fundamentals of storage, like how storages are working, and there will be some non-intuitive, terms while we're understanding computer storages with the help of transistors, like how transistors, storages, and units are correlated with each other. Actually, I was planning to make a lecture video upon image analysis in machine learning. Through that lecture, I will be able to teach you about the large language model and the small language model, like how the image recognition works in small language models and AI models, right? So I thought of that it is important to understand the fundamentals. Like there will be a non-intuition if you don't understand computer storages, like how the images are being stored in the computer. So I don't want it to create a non-intuitive part in the particular lecture. So yeah, that's why I'm teaching this. The lecture will be short and will be focusing towards the basic overview, right? Because if you want to learn more about nanotechnology, transistors, then you can go check out my video of nanorobotics and nanotechnology. There we will find much information about transistors and nanotechnology, like how the signals are being transferred and converted and interpreted, like transistor signals and voltage detection. We will be focusing upon the correlation of transistors, computer storages, and their units. Units is one of the most important thing. Like they all are correlated. So we will understand the basic nanomechanics of the transistors. We will understand that how transistors are being used to store data and how many transistors are being used to store 1 gigs of data. So first of all, let's learn about the nanomechanics of transistors. Right. So you can consider transistors as an on-off switch. Right. Now, as we know that there are two stages of transistors, that is either on or off. So when the transistor is detecting high voltages, it is interpreted as 1 true. When the transistors are detecting low voltages or maybe 0 voltages, it is interpreted as 0 and false. And as we know that these two values are binary values. Binary values. So yeah, a transistors is basically used for computers to communicate and understand in the binary form. Like this is the real reason why computer only understands binary form, binary number systems, because the system itself is working upon transistors, and transistors can only represent 0 and 1. And the further 0 and 1 are recognized and interpreted as false and true, maybe positive and negative. That why computer only understand binary values is the reason transistors, because they represents only 1 or 0 at a particular time. As I have taught you a brief introduction about transistors and being used in classical computers, because they can only represent a single value at a particular time, either 0 either 1, right? And in qubits, the 1 and 0 are represented at a particular time. So this was the basic mechanism of transistors, like the basic properties, of the transistors in its two stage. Right. Now let's understand how transistors are being used to store data. So suppose we have a letter A, or maybe a color yellow. So how these datas, digital datas, are going to be stored in the computer? Like how transistors are gonna play their role? Any idea? Well, these digital datas are converted into their binary form. So letter A is denoted as in its binary form, that is 1101, and the yellow is pretty big. Uh, so let me write. There are continuous three ranges of RGBA. Like if you have used stylings and website, and if you have ever used color palettes, there are RGBA and different ranges. So in yellow, the numerical value of yellow is 25, 255, and 255 and 0. Right. So there are two the full ranges in red and blue, and there will be no range for blue, right? The full range is in red and green, right? There's no blue. So in binary form, they're converted as 8 continuous 1, again an 8 continuous 1, 8. So yeah, this particular thing is yellow color, right? This is the binary form of yellow color. So why 8 1, right? So if you convert this 255 into its binary form, right, as we know that in our grayscale, no, sorry, not grayscale, in a color scale, range, or maybe you can say limit is from 0 to 255, right? I remove this, right? So you can understand that is particular thing like that. That's why there is full ranges on red and green, but there is no range in blue. That's why they all are empty, and for those red and green they're all full with one. But yeah, that's not a way that you can read binary number systems. Like this is not human readable, only machines can understand this. So yeah, you cannot read this. So this was not a logic of understanding binary numbers. I just stated a simple logic of understanding why this pattern. Because if I change a single digit here, the total color will be changed. So that's why there's no way that you can read this binary number systems and binary language. Only computer can read this. Okay, so here what I'm seeing, let's just take an example of A. So there are values of 1101. And as I have told you earlier that a single transistor can represent only single value at a particular time. There are four values, right? So there must be four transistors being used. What is represented by binary number system? Obviously the transistors, when they detect or higher voltage and low voltages, then the binary numbers are represented in computer systems. So if it is stored in such way, so there will be four transistors which will be in the alignation of on off and on, right? So 1 1 0 and 1. So there are four transistors which is being used to store their signals are being stored as letter A, right? And obviously their signal can't be in human language. They are representing 0 and 1. That's why computer only understands the binary language, that does not understand the human language. I hope that you understand that there are four transistors which are representing the values of binary form of letter A, and that's how transistors are being used to store this letter A. So when you turn on your computer, right, where are these transistors? Basically they are processors, they're present in the RAM, they're present in the ROM, they're also present in the hard drives, right, wherever. So I will teach you that, like how hard drives uh, are able to store the storages and process those data, right. So I hope now you understand. Like, let me recap that this letter A and its binary form, because obviously if it is wanting to be stored in the computer, it will be converted into 0 and 1, because computer only understands that particular function. This all command which I'm saying is computer algorithm. Like, computer algorithms are made in such way that they are obviously allowed to store everything into these forms, right. So it is automatic. You're not able to, stop it. You are actually, you can remove that hardware, but the algorithm you cannot remove it. So yeah, that is an inbuilt system, inbuilt integrated programming system or algorithms. And same goes for yellow color. Like, you can count how many digits are, as I've said, that there are 8 continuous one in the single range of red. Then there's again 8 continuous one in the single range of green, and there's continuous 8 in the single range of blue. So there are 8 into 3 transistors being used as 24 transistors. And as you can see that if we just store the letter A and a yellow color in our computer, it requires how many transistors? 24 plus 4, that is 28 transistors. Simple data forms, a yellow color and a letter A, and single alphabet. Small a, it also requires 4 bits of data, like 4 transistors. I will tell you like what is 4 bits, why I'm relating 4 bits to transistors, like to 4 transistors. So yeah, that's why computer systems have inbuilt printed millions of transistors. Actually, not millions, there are billions of transistors. Millions is a very small word, because just imagine how much data, how much complex data is being stored in your computer. Like, you have games, you have basic applications, you have operating systems, there are calculations in the games, maybe in the applications, the font styling, the commands, all are being converted into binary form, and every binary form is represented by single transistors. Like, every value, each value is represented by a transistor, a single transistor. So obviously a million sounds small, even billion sounds small. Okay, now how transistors are correlated with storages. Basically they're units. Now I'm just gonna tell you how the units is being correlated by this particular thing, transistor. So let's take that example of letter A again. A, which is being converted into binary form as 1101, right. And there are 4 transistors, right. There are 4 transistors. Do you know this particular thing is also known as 4 bits? Actually, the value itself is 1 bit. If transistor representing 1, it is also called 1 bit. Yeah. As I've told you in my quantum computing lecture, if you remember, if you don't remember, you can check it out as well. That computer uses bit system, where quantum computer uses qubit system. So the quantum bits represent 0 and 1 at the same time, where the bit system represents only 1 or 0 at a particular time, but the value does not change. If it is represent, if transistor representing 0, it does not mean there are 0 bits. There is still 1 bit, and the both together becomes 2 bits, and 2 bits have 2 transistors, because obviously a single value which is being represented by which kind of machine, transistors, and the transistors are representing a particular value, and that particular value is called bit. And then the combined whatever how much amount of values are there and how much transistors are being used to store the particular data. So that is how it is correlated with the units. Let me tell you the brief conversion. You have a familiar idea from your high schools that 8 bit is equals to 1 byte, 1024 bytes is equals to 1 kilobytes, KB. 1024 kilobytes is equals to 1 megabytes, and 1024 megabytes is equals to 1 gigabyte. These are the basic transitions of data from bits to GB. There are more such bigger, there are, if 1024 MB, sorry, GB is equals to 1 TB, and there's more, yola-byte, zettabyte, exabyte. So as I've told you that 1 bit is equals to 1 transistors. I will write transistors as TRN. Let's suppose TRN is transistors. 1 bit is equals to 1 transistors, and the 1 transistor is equals to either 1 or 0, binary value, right? So that's how the transistors are correlated with storages and their units, right? So actually a value which is represented by transistor is considered as 1 bit, and as we knew that for letter A there's being 4 bit, because the value of A was 1101, right? The value of A was this particular in its binary form. So there are 4 bits because there are 4 values represented by 4 different transistors for wait, right? So it will be said as 4 bits. I hope you understand this particular map, like how transistors and the storages and the units are correlated. Now there's much more to understand in this particular field, because now there's a numerical. Just imagine if 8 bits is equals to 1 bytes. So there are 8 transistors in 1 byte. Suppose if I'm asking you that an image which is being stored in computer occupies in a space of 1 byte, then tell me how many transistors is being used in 1 byte. You will answer, sir, 8 transistors, right? But what if I ask you that I have an application which is, suppose I have a image captured by a cinema camera, red, maybe blue. So how many transistors are there in 1 GB? How many transistors? So you have to go with the unitary method, right? You will first calculate how many bytes are there in 1 GB, then you will calculate how many bits are there in that amount of bytes, and then you'll get the answer. So yeah, that's the whole thing we know about the transistor. That is very logical but also non-intuitive at a particular site, because when you're new to this field you have problems while understanding these concepts. Okay, now let's understand like how ssds, rams, hard drives, rom store datas. As I've told you that there are transistors. um, Suppose we have ssd, there must be transistors in the ssd. Storage capacity 1 byte. Yeah, so this is enough for you to understand, right? If I take the larger value, it will take you years to understand this particular topic. So yeah, So this SSD must have transistors. There will be 8 transistors because 1 byte is equals to 8 bits, and single bit is also single transistor, 8 bit is equals to 8 transistors. That's simple it is. Transistors are also often called non-detecting transistors. Now, what is the concept of non-detecting transistors? Like, why we are saying this non-detecting transistors? In computational term, you will understand as of now because as it is non-detecting, like the voltage will be low, and the all transistors in the alienation of zero. Non-detecting transistors have another concept. As we say that our storages of mobile phones are full and we have to clean it up. So why this happens? Like we often used to say that, oh, I think I need to buy external SSD or external pen drive so that I can store some of my data in that, because my data is full. How that is getting full? There's a simple answer, that maybe all the transistors, suppose we have one byte of storages, right? So all the transistors are in use, so we don't have any space left. So actually what happened is, you're right that if the transistor is non-detecting, in the stage of non-detecting or detecting lower voltages, it will be all aligned to zeros, right? There are six. Okay, let me add eight. Right, all are zeros. But suppose we have added an image inside the SSD, which is of suppose 4 bits. An image, an SSD, the image size is 4 bits. Now, these non-detecting transistors, any four of them will be, suppose this 4 will be in the alienation of 0 1. So now these four transistors are not no more non-detecting. They're often called occupied occupied cells or occupied transistors. So now your computer will say that SSD had 1 byte in total, but now only 4 bit usable. So this was the concept of non-detecting transistors. If transistors are detecting low voltages, or maybe they are marked up as non-detecting transistors, basically this is happened due to the algorithms, you know, storage drivers. You know, you have plenty of drivers in your computer. So the drivers are the algorithms which is used to run different parts of the computer in a particular protocol or in a particular way, that it does not interrupts the continuous system, right? So basically these are secondary storages. SSD is a type of secondary storage. So the basic algorithm understanding of secondary storage is that they are not directly used as storage device. Like if you are allowing some kind of file or some kind of data to be stored in this particular storage, then only it will be storing to the storage system, right? Whereas primary storages, which is RAM, a best example is RAM. So whenever you turn on your computer, RAM is being used without a permission. Also, RAM are volatile. Volatile means memory it accesses will be fully removed. That's why they are in a lesser space. The RAM is 8 gigs of RAM, 16 gigs of RAM is enough. But you buy 1 TB SSD, 512 GB SSD, because they are data which are going to be stored for permanent basis. But here the storage is not permanent. So there are different types of storages. Like in RAM there are storages working upon storages depending upon the application you're using. Right, the data of application is being stored in the RAM, but the application itself, the installation of application is being stored in there. The BIOS, the basic input and output system, is stored here. Like your Windows run upon this, but your Windows is installed in SSD, but it run upon this. That's why it is known as the random access memory. It accesses the memory. It accesses memory, like it is accessing programs from SSD for real time working, and is removing its data. Because if it is not able to remove its data, then it will be full, and you know that is not how those things are supposed to be. Because the permanent storage is SSD. This is supposed to store data for permanent basis. This is just to access the data, work upon it, and then just clean it up. And the work is done when the application is closed and when the computer is turned off. If your computer, suppose having 4 bits of usable data, so we'll say that there are 4 transistors which are in non-detecting phase. They are non-detecting transistors. 4 transistors are non-detecting. Empty space. If your computer have lots of storage, then you will say, I in my computer there are lots of non-detecting transistors, because that particularly means that those transistors are being used to store data. And if the transistors are occupied, that you call particularly the space is occupied, right? A non-detecting transistor phase is basically dependent upon their computer algorithms of drivers which is being used to control the storage systems. It may be the storage system itself, right? Actually, the values of transistors can be used in whatever system requirement is, right? Like if you want your computer system to understand 1 as a particular name and 0 as another name, so you can do that by making a program on that application, right? So the computer drivers identify the empty spaces or the transistors which are not involved in storing data as non-detecting transistors. So that's why they are said to be non-detecting transistors, because they are not being used to store some kind of data. So this was the basic overview about non-detecting transistors. I've discussed a lot about this because this was also non-intuitive, and you may have learned something new about like what are the uses of drivers, right? Actually, this is the very brief introduction about this, because the whole thing is itself an engineering. So I'm just telling the basic overview. Like you will require this particular knowledge in image analysis and machine learning. So that's why I'm telling you. But there are more such numerical based practices. Uh, so you learn these all things in nanomechanics, but the basic overview is still taught in machine learning. When we will be learning image analysis, the image recognition models, we will be using these concepts as a fundamental an image analysis, right? So yeah, I hope that you understand these concepts. There are plenty of intuitions. If you have any confusion, doubts, please do ask me in comments. I will definitely try my best to reply you in the perfect way, in the best manner. And till then, take care everybody, and bye bye. Keep studying well. Jai Hind.